Archiving started.
This is Professor Bob Young. In this instructional video, we're going to look at the point slope form, which I like to call the equation writer when it comes to writing equations of lines, and also the slope-intercept form. Now we're going to look at this handout that was given out in both lecture and hybrid classes entitled Graphing Linear Equations, and online students can access this in Angel. And we're going to look at these two boxes in this video, the one on point slope form and the one on slope intercept form. So just keep that in mind as we progress. Now the point slope form, or what I like to call the equation writer, if you're given a point or 2 points and a slope, this is the place to go right here, and we're going to show you that with some examples. All right, so it says find the equation of a line through the point -4, 1 and having slope equal to -3. So what I like to do here, and let me go to my colors, is I like to, whenever I'm given a point or 2 points, I like to tell students to label them. So we're going to label this point x1, y1 given, and we're going to take and label the slope number -3m. And then we're going to take, and this is like the Glade commercial now, plug it into the equation writer. So here we go. We're going to say y minus y1 would be y minus 1 equals m, which is the slope, -3, times x minus x1, which would be x minus -4. Now you can see where students could make sign errors here, so be careful. So that minus negative becomes plus. So we end up with y minus 1 equals -3 times x plus 4. Now let's solve the equation for y by distributing the -3 through. So that'll give us y minus 1 equals -3x minus 12. And then adding 1 to both sides of the equation, we end up with y equals -3x plus minus 11. Now another point to make here, no pun intended, get it, another point to make, is that we can take this point, -4, 1, plug it back into the equation we found and check it and see if it makes sense. So in other words, let me take and plug in -4 down here for x and see if y comes out to be a +1. So if I take -3 times -4, I get a +12, subtract 11, it does come out to 1. So it makes perfect sense in our answer, so that's always a good feeling. So check and make sure that any point or points given satisfy your equation. All right, now let's try another example here. It says find an equation of a line through the 2 points, -3, 2, and 2, -4. So again, I want to label these points here, and I'm going to come up here on the top, and let's label this first point x1, y1, and the second point x2, y2. Now we're going to go ahead and find the slope first, because if you don't have the slope of a line, you can't write any type of equation here. So again, we're going to plug in the slope formula that we've used in the videos previous to this. So slope equals y2 minus y1, which is -4 minus 2, divided by x2 minus x1 would be 2 minus -3. Watch those signs again, and you get a slope of -6/5. Now, whenever you're given 2 points, you can use either one of them in the equation writer. So you could use the -3, 2 or the 2, -4, but let's go ahead and choose the -3, 2 since we did up top there as the x1, y1 when we plug in here. So we're going to end up with y minus y1 is y minus 2 equals -6/5 times x minus x1, which would be x minus -3, watching those signs again. And I guess we're going to have to go ahead and finish solving this one for y. I got a little bit ahead of myself there. Sorry about that. So y minus 2 distributing here is going to be, and watch out here, this is going to become a plus 3, that minus negative, all kinds of viciousness here. So we're going to get negative 6/5 x minus 18/5. And to solve this for y, we'll go ahead and add 2 to both sides of the equation. So y is going to equal negative 6/5 x. And then if you want to go ahead and take negative 18/5 plus 2, we can change 2 into a fraction, 2 over 1, get a common denominator of those two fractions, which would be 5. And then 2 becomes, multiplying top and bottom by 5, 10 over 5. So we would have minus 18 over 5 plus 10 over 5 would be a minus 8/5. All right, would that answer check? Both of these points should check that answer. So I'm going to take the 2 negative 4 here, plug it in, and make sure it makes sense here. So in other words, y will be negative 4 to check this when x is 2. So always check your equations, make sure they make sense. All right, so 2 times negative 6/5 here on the right would be negative 12/5. Y'all know how I got negative 12? Negative 6 times 2. Minus 8/5. And if you put those together, you would get a minus 20/5, which sure enough reduces to negative 4. So again, we know our equation is right. And also the other point would work in there as well. Now onto this graphic that I almost stumbled upon earlier, the slope-intercept form of the equation of the line. Y equals mx plus b. I know many of you have heard this before, where m is the number in front of x, that's the slope, rise over run. B is the y-intercept of the line. And this really comes from the equation writer, the point-slope form. See, this is a special case where someone took any point that may cross the y-axis, and they called that point 0b. And then they just took any slope m, and they went ahead and they did the y minus y1 equals m times x minus x1, and they used the point 0b as x1, y1, with some given slope m. And then when they solve for y, lo and behold, from the equation writer from point slope came slope-intercept form. So then they'll give you some problems and some equations, and they'll say, find the slope and y-intercept of the line with this equation. So, and I will also go back to one of the previous slides in your handout here. And notice when you're going from point slope form to slope intercept form, you can change from all of these forms to any others just by some algebraic manipulation here. But Young put some good notes here in the middle. Solve the equation for y to get to this form. All right, so that's what we're going to do here. So to find the slope and the y-intercept, we're going to go ahead and we're going to subtract 4x from both sides to get y by itself. That leaves us with 5y equals negative 4x minus 10. Divide both sides by 5, and lo and behold, we end up with y equals negative 4/5 x minus 2. Let's graph that real quick. Y equals negative 4/5 x minus 2. Now, whenever you graph in this slope-intercept form, this y equals mx plus b form, I always like to tell my students to start here. Always start at the y-intercept point. So if I was graphing this one, it would be at negative 2. Start here. Go here. I give such complex notes here. Go here. So in other words, use the slope to get your other points on the line. And remember, the slope definition is rise over run. And rise is the change in y. So we would go down 1, 2, 3, 4, run 1, 2, 3, 4, 5, and then that would be that point. And we could do that forever and ever. We could go down another 4, and then over 5. But let's just go ahead here. It just takes 2 to tango when you're graphing lines. And we will connect the dots here. And I'll go a little bit the other direction here too, just for good measure. And I always like to put arrows on my lines to show they go on forever without end. So the domain and range on this one would be negative infinity to infinity. All right, it says find an equation of the line through 1, 1 and 2, 4, then graph using the slope-intercept form. So this is similar to the example we did before, and we'll kind of speed through this one a little bit quicker. So again, label those points, folks, x1, y1, and x2, y2. And notice we had to find the slope again first, y2 minus y1 over x2 minus x1. So the slope came out 3. And now, let me peek ahead to this next graphic here. I may have to back up. Nope, we're going to stay with this one. So we're going to go ahead and put 1, 1 in, since it comes first for the x1, y1 here, and the 3 for slope. And I guess I'm going to have to back up and solve this one here. I keep getting ahead of myself today. This is just one of those days where I'm just getting ahead of myself. So let's plug it in. So y minus y1 would be y minus 1 equals 3 times x minus x1 would be x minus 1 here. Distribute the 3 through. Y minus 1 equals 3x minus 3. And solving for y, getting y by itself by adding 1, we're going to get y equals 3x minus 2. Now, if I plug 1 in for x here, will y come out to be 1? It checks. If I plug the other point up top in, if I plug 2 in for x, does y come out to be 4? Yes. I'm feeling good about things. So now let's go ahead and graph this line y equals 3x minus 2 here. And you know where I'm going to start, right? I'm going to start the y-intercept at -2, and then in class I'll tell my students, tell me where to go from here. And a lot of them will go, I'll tell you where to go, young. And I'll say, hey, now be nice. So you have to change 3 into a fraction, so make it 3 over 1. So we're going to rise 3, run 1. And there is our second point. So I just went up 1, 2, 3, and then over 1, make your line. And let me get my line tool here. So graphing linear equations, not too bad. Say it's easy for you to say. But with practice, you can be this good too. All right, now we can also find equations from graphs. So it says use the graph of the linear function f here to complete the following. It says find the slope and y-intercept and x-intercept. And then use, it says, so if we keep going here, the line falls 1 unit each time the x value increases by 3. So if you want to, just go ahead and put a point here. Now it sure looks to me like it crosses right here and right here. So if I were to use this rise over run concept, I would rise from this lower point 1 in a positive direction. Okay, so that's going this way. And then I would run 3 this way. Now notice down here, it looks like they started, you know, you can get negative 1/3 other ways as well. You know, if you started at the top point there, you would, now let me show you something here. This is kind of cool. If you started at the top point, you could go down 1 and right 3 in a positive direction, but no matter which way you go, you're still going to end up with this negative 1/3. And with the y-intercept here at -1, let's think about this here. We've got y equals mx plus b. So we could say that y equals negative 1/3 x minus 1 from that picture. What do y'all think? And this just goes on to explain it some more there. It says, notice that the y-intercept is -1 there. The line intersects the x-axis at negative 3, 0, so that's one other thing in here. The x-intercept is negative 3. And voila, in functional notation, we just change y to f of x. There you go. All right, so this was the equation writer, writing equations of lines using point slope form and slope intercept form. Bob Young signing off.